Let's get into it. Number 10. Kelt 9b. A planet should not be hotter than a star. That is a fairly basic expectation. Kelt 9b ignores it. The dayside temperature reaches roughly 4,300 degrees Celsius. To put that in context, our sun's surface sits at about 5,500. Kelt 9b is cooler than the sun, but it is hotter than roughly 80% of the stars in the Milky Way. Most red dwarfs, most orange dwarfs, and a fair number of yellow stars are cooler than this planet's atmosphere. That sentence should not be possible, but the measurements from B. Scott Gotti's team at Ohio State in 2017 confirmed it. The planet is about 3 times the mass of Jupiter and orbits its host star in just 36 hours. It is tidally locked, meaning one face points permanently at the star, soaking up radiation without relief. At those temperatures, hydrogen molecules get ripped apart into individual atoms. They drift to the night side, cool just enough to recombine, and then circulate back to the day side, where they are torn apart again. An endless molecular cycle of destruction and reassembly, happening across the entire atmosphere, every single orbit. The host star itself is an A-type, burning at nearly 10,000 degrees Celsius, and it is bombarding the planet with so much ultraviolet radiation that Kelt 9b is actively losing its atmosphere into space. There may already be a tail of escaping gas trailing behind it, similar to a comet. At some point, the planet will lose enough mass that it stops being a planet at all. What's left after that, nobody can say with certainty. A stripped core, a remnant, or nothing. A planet hotter than most stars, being cooked alive by the one star that outshines it. And that is only number 10. Number 9. HD 119733b. It looks blue. A calm, familiar blue, the kind your brain files under ocean or sky. Your brain is lying to you. That blue comes from silicate particles suspended in an atmosphere hot enough to glow. Glass. When those particles cool, they condense into molten droplets and fall sideways, driven by winds clocked at more than 5,000 miles per hour. Not a breeze. Not a gale. A wall of superheated air moving 7 times the speed of sound, dragging liquid glass with it. Tom Evans and his team at Oxford confirmed the color in 2013 using Hubble's spectrograph. Before that, nobody was sure why the planet looked the way it did. Turns out the answer was worse than anyone expected. It is beautiful the way a loaded gun is beautiful. Which is to say, it is not beautiful at all, once you understand what you are looking at. The host star hammers the atmosphere with X-ray flares so regularly that the upper layers are boiling off into space. You can actually track the mass loss. The planet is evaporating, slowly but measurably, a blue jewel bleeding itself dry in the dark. So why do we keep studying it? Because at 64 light-years away, it is close enough that our instruments can read the atmosphere in detail. HD 1A9733b is the punching bag of exoplanet science. We learn by watching it get destroyed. If burning glass rain sounds bad, wait until you hear what happens when ice refuses to melt. Number 8. Gliese 436b. It is about the size of Neptune. It orbits a dim red dwarf so closely that a full year takes 2.5 Earth days. The surface sits at roughly 440 degrees Celsius, which is comfortably past the melting point of lead, zinc, and your will to live. And yet, there is water ice on this planet, not the ice in your freezer. A high-pressure crystalline form called Ice 7, forced into a rigid lattice by the planet's own crushing gravity. The temperature says it should boil. The pressure says it cannot. Physics wins both arguments simultaneously, which is the kind of result that makes theorists go quiet for a while. David Ehrenreich at the University of Geneva found something even stranger in 2015. Ultraviolet observations showed a colossal tail of hydrogen gas streaming off the planet, stretching behind it like a comet. Gliese 436b is a world wrapped in ice that should not be solid, bleeding an atmosphere it should not be losing, trailing a tail that should not be there. 3 violations of common sense orbiting a forgettable star 30 light-years from here. The atmospheric chemistry doesn't help either. There is far too much carbon monoxide and almost no methane. At these temperatures, the carbon ought to favor methane. It does not, and the models arguing about why have been arguing for over a decade without a clean answer. A planet made of contradictions, burning ice, backwards chemistry, and a slow death by evaporation. It exists because nobody told it the rules. Compared to Gliese 436b, the next planet skips the contradictions and goes straight to violence. Number 7. 55 Cancri e. It finishes an entire orbit in less than 18 hours. It hugs its star so tightly that the day side reaches as around 2,700 degrees Celsius, and at that temperature rock stops being solid ground. It becomes a liquid. The entire sunlit face is covered in a churning global ocean of magma. In 2012, Niku Madhusudan at Yale published a paper arguing the interior was carbon-rich, dense enough under pressure to contain layers of diamond. The press loved it. Diamond Planet. Every headline wrote itself. The name stuck for years, even as the science moved on, because nobody runs a correction on a headline that good. What actually changed the picture was Webb. In 2024, the James Webb Space Telescope detected carbon dioxide and carbon monoxide in the atmosphere, which should not be there. A planet this close to its star, this battered by radiation, should have had any atmosphere stripped bare billions of years ago. The fact that gas persists suggests the magma ocean below keeps vomiting new volatiles into existence faster than the star can tear them away. So the planet breathes. Through molten rock, endlessly replacing what it loses. That is not in the textbook because, until Webb, nobody knew it happened. The flip side of a planet desperately clinging to its atmosphere is a planet that has already lost the fight. Number 6. WASP-12b. It has roughly 3 million years left, possibly less. It orbits at about 2 million miles from its host star. A full year lasts 26 hours. The star's gravity has warped the planet into an egg, which is the polite way of saying the tidal forces are pulling it apart the way you pull taffy, slowly and from both ends. 6 billion tons of atmosphere ripped away every second. That gas spirals inward, forms a disk around the star, and falls onto the stellar surface. The star is eating the planet. Not metaphorically, observably. Leslie Hebb's team at Vanderbilt discovered it in 2008, and every measurement since has confirmed the same trajectory. The orbit is decaying. The gap is shrinking. The math gives it a few million years, which in cosmic terms is next Thursday. That makes 4 planets so far that should not be what they are. The next 2 make that problem worse. What makes it worse is the color. The surface temperature hits 2,600 degrees Celsius, hot enough that the planet glows, but it reflects only about 6% of the light that reaches it. Darker than fresh asphalt. Almost as dark as the next planet on this list, which raises a question. Number 5, Tries 2b. How dark can a planet get? Darker than coal. Darker than the blackest acrylic paint on the shelf at your hardware store. Darker than anything in our solar system by a wide margin. TRES-2b reflects less than 1% of the starlight that hits its atmosphere. 1%. David Kipping and David Spiegel at Columbia published that number in 2011, and it has held up under every subsequent check. The planet absorbs virtually everything and gives back only a faint red glow from its own heat, like a dying ember floating 750 light-years away in the constellation Draco. Why is it this dark? Probably vaporized sodium and potassium, possibly gaseous titanium oxide. Those compounds absorb light aggressively, but even all of them together do not fully account for the measurements. Something else is swallowing those photons, and we have not identified it. That is the part worth sitting with. We found the darkest planet ever measured, and we still do not completely understand why it is that dark. Sometimes the discovery is just the beginning of a longer question. If a planet that eats light sounds hard to explain, the next one breaks the models in a completely different direction. Number 4. WASP-193b. How much should a planet weigh? If you handed a physicist a planet 1.5 times the width of Jupiter, they would estimate a mass somewhere north of Jupiter's. Sensible guess. Wrong by a factor of 7. WASP-193b has only about 14% of Jupiter's mass. Run the density calculation, and you get 0.059 grams per cubic centimeter. Cotton candy comes in at about 0.05. So we found a gas giant with roughly the structural integrity of the stuff they sell at fairgrounds for $3 a bag. Khalid Barkawi's team at the University of Liège published this in Nature Astronomy in 2024. And the tone of the paper was unusually direct for a peer-reviewed journal. They stated plainly that no existing model, not even under the most generous theoretical assumptions, could reproduce these numbers. Strip the core out. Assume pure gas. It still does not work. To stay inflated at this size, the planet would need a persistent energy source pushing outward from deep in the interior. What source? Nobody knows. There is no established mechanism that can keep a gas envelope this bloated for this long against a star that should be stripping it away orbit by orbit every 6.25 days. There is a version of this planet that collapses. There is another version that gets peeled apart by radiation. Neither version exists. This one does. It just hangs there, lighter than it has any right to be, waiting for someone to explain it. WASP 193b breaks the rules of mass. The next planet breaks the rules of birth. Number 3. TOI 5205b. It is roughly the size of Jupiter. Its host star is a red dwarf with about 40% the mass of our Sun. According to every standard formation model, that star's protoplanetary disk should have contained roughly 4 or 5 Earth masses of solid material. To build a Jupiter, you need at least 10 Earth masses of rocky core to trigger runaway gas accretion. The budget was short by half. The planet should not have formed. Period. Shubham Kanodia at the Carnegie Institution announced the discovery and called it the Forbidden Planet. Not for drama. Because the name is a precise description of the theoretical problem. When the planet transits its star, it blocks about 7% of the light, an absurdly large dip because the planet is nearly as wide as the star itself. Webb followed up on the atmosphere, and the results were characteristically confusing. The planet's atmosphere has fewer heavy elements than the star it orbits. That is backwards. Planets almost always concentrate metals beyond what their parent star contains. The current theory is that the heavy material sank inward during formation, leaving a metal-poor atmosphere sitting on top of a metal-rich core. A stratified planet that formed where it shouldn't have, around a star that couldn't support it, with chemistry arranged in ways nobody predicted. If you are keeping count, that is 8 planets so far that violate at least one supposedly firm rule of astrophysics. The next one violates the most dramatic rule of all, which is that you cannot survive being swallowed by a dying star. Number 2. Hala. It should be ash. The star it orbits is called Bakdu, a red giant burning through the final stages of its fuel. As red giants expand, their outer layers swell outward, sometimes far enough to engulf close-orbiting planets. Standard models say Bakdu's expansion should have reached well past Hala's orbit. The planet should have been dragged inward, cooked, and absorbed. There should be nothing left. So why is it still there? Mark Hahn at the University of Hawaii led the team that confirmed Hala was real and still there, orbiting inside the zone the star once occupied. The implications are genuinely unsettling. Either the planet survived inside the body of an expanding star, which would mean planets are far more durable than any model suggests, or the star's expansion history was different than predicted. The leading theory is that Bakdu was originally a binary, 2 stars orbiting each other. At some point, they merged, and that merger may have altered the expansion just enough to spare the planet. There is also a stranger possibility. Hala may not be the original planet at all. It could be a second-generation world, born from the debris cloud of the merger itself. A planet assembled from the wreckage of a stellar collision. The official catalog number is 8 Ursae Minoris b. The team named it Hala after the highest mountain in South Korea because something that refuses to die deserves a better name than a string of numbers. And now the final entry. A world so strange that calling it a planet might be the most generous classification in astronomy. Number 1. PSR J11719-1438b. It orbits a pulsar, a neutron star about 20 kilometers across, spinning hundreds of times per second, broadcasting beams of radiation with the precision of an atomic clock. The planet completes an orbit in just over 2 hours. 2 hours. At that proximity, the tidal forces have crushed it out of round into something closer to a lemon, compressed and distorted by gravity that would flatten anything built by human hands. The atmosphere, if you can call it that, is dominated by carbon and helium rather than the hydrogen you would expect from a gas giant. Spectral analysis found layers of soot like molecular carbon in the upper atmosphere. Deeper down, where pressure builds to millions of atmospheres, that carbon may be compressed into crystalline diamond. Rain made of diamonds, falling through clouds of soot, onto a world shaped like a citrus fruit orbiting the spinning corpse of a dead star. But the part that genuinely disturbs planetary scientists is this. PSXR J1719-1438b may not be a planet in any traditional sense. The leading theory is that it is the exposed core of a white dwarf, a companion star, that the pulsar slowly consumed over millions of years, stripping away the outer layers and leaving behind this dense, deformed remnant. We call it a planet because it orbits something and has roughly planetary mass. But it might be a stellar carcass, the leftover bone of a star that was eaten alive. Alexander Volshan discovered the first pulsar planets back in 1992, and that discovery was already difficult for people to accept. A planet around a dead star felt wrong. 30 years later, we found something worse. A planet that might be a dead star itself, orbiting the thing that killed it. 10 planets. 10 violations of the rules we thought governed the universe. A planet hotter than most stars, glass rain, burning ice, cotton candy giants, forbidden births, stellar survivors, and the stripped remains of a murdered star still circling its killer. The weirdest part is not any single discovery. It is the pattern. Every time we point a better telescope at the sky, we find something that should not exist. And every time, it does. The only question left is what the next telescope will find that makes this list look tame.